Fort Valley, Georgia, 1925, early fall. Albert L. Luce Sr. owned two Ford dealerships, one in Fort Valley, the county seat of the newly formed Peach County, and one in the neighboring town of Perry. He had sold a customer a bus, a wooden body mounted on a Ford Model TT truck chassis. The customer intended to use it to transport workers. The body was standard, the kind of construction regional coach builders across Georgia had been producing for years. Pine frame, poplar boarding, assembled on the chassis and sent out to do the work a bus was meant to do. Luce had sold the chassis, he had brokered the body, and now, before the customer had finished paying for either, the body was failing. Not from an accident, not from unusual use. The Georgia roads had done it. The county roads running out of Fort Valley in 1925 were unpaved. Red clay surface, cut through a flat Piedmont landscape of peach orchards and pecan groves. Their condition depended on what Georgia weather provided. In dry fall weather they were passable. In the wet months they became what Georgia drivers of the period called gumbo mud. A red clay surface that was neither solid nor liquid, that built up on tires and undercarriages, and turned slight grades into obstacles. A wooden bus body bouncing over these roads twice a day, 5 days a week, absorbed the vibration into every joint and fastener it had. By early fall, before the first wet season had even arrived, the body Luce's customer was still paying for had already begun to work itself apart. Luce told the customer he could probably build a better bus. The customer told him to try. What Luce decided to build, and why the specific problem of a middle Georgia county road led to a specific design decision that would eventually change what an American school bus was made of, begins here in Fort Valley, with a failing wooden bus body on an unpaved Peach County road in 1925. What had those roads been doing to wooden bus bodies across middle Georgia? And what specific solution did a Fort Valley Ford dealer decide to build? By 1927, Albert Luce had built his answer. Not a revised wooden body with better joinery, a body with a steel structural framework, angle iron roof bows, steel framing members, replacing the wood skeleton that had been failing on Georgia roads. Wood still appeared in the body construction. The roof was canvas, but the structural integrity now came from steel. The frame that transferred the road's forces into the body was metal, not pine. The joints that vibration had been loosening were metal joints, not wood screws. What the Georgia County road did to a wooden skeleton, the cyclical stress, the moisture absorption, the loosening through repetition, it could not do in the same way to a steel frame. Luce sold the bus in 1927 to a buyer in a nearby town. It was put into use transporting school children. After that first bus, he built 7 more. That first bus still exists. Bluebird No. 1, the 1927 vehicle built in the back of a Ford dealership in Fort Valley, Georgia, is at the Henry Ford Museum in Dearborn, Michigan. It has been through 2 restorations. The Luce family reacquired it in 1946 and placed the body on a Ford Model TT chassis. A second restoration followed in the 1970s. It was donated to the museum in 2008. The 80th anniversary of its construction, it is documented as the oldest surviving school bus in America. But in 1927, it was not a museum object. It was a working bus on a Peach County road, carrying farm children to a small Georgia county school. The problem it had been built to solve was not abstract. It was specific. The failure mode of a wooden bus body on a red clay county road, experienced once by a Fort Valley Ford dealer watching a customer's purchase fall apart before the payments were complete. The company that would eventually carry the solution across North America did not yet have a name, a factory, or more than 8 buses to its credit. What it had was a frame that held together on the road that had beaten the previous one. What was it specifically about the roads and conditions of middle Georgia that a wooden body could not withstand? And what did steel give a bus body that wood could not? Before we continue, if this kind of documentation is what you've been looking for, consider subscribing. Every video on this channel goes into one specific element of American school bus culture from 1930 to 1980. What the bus was, how the route worked, and what the driver and the children inside it knew that no school district record ever captured. Not nostalgia for yellow buses, the documented operational and human reality of a system that carried an entire generation to school. In 1927, a Ford dealer in a Georgia peach farming town solved a specific problem with unpaved roads and a failing wooden body, and that solution became the structural logic of American school bus manufacturing for the next half-century. And if you rode a Bluebird school bus anywhere in the South, anywhere in the country, or if you drove one, or if your family had anything to do with the buses that came out of Fort Valley, put it in the comments. What do you remember about the ride? What the 1939 National School Bus Standards Conference established, and how 12 years of building to Georgia road conditions had already put Bluebird ahead of the bar those standards set, is the subject of the next video. Back on the Peach County Road. To understand what the wooden bus body had been failing against, you need to understand what a Peach County road was in 1925. Peach County itself was only a year old. It had been carved out of sections of Macon and Houston counties in 1924. A new county with new boundaries, centered on Fort Valley, its road network the accumulated result of farm wagon access and railroad support. Not motor vehicle planning. The flat Georgia-Piedmont terrain meant that drainage, not grade, was the primary road management challenge. Water did not run off the surface quickly. It absorbed into the red clay, which then shifted its character entirely. Dry, it was a firm, dusty surface that supported loaded vehicles at normal speed. Wet, it became something else. The red clay of Middle Georgia in prolonged rain was not mud in the ordinary sense. It was a surface that looked solid, held a vehicle's weight for the first few passes, and then gave way, not suddenly but progressively, each pass sinking the wheels a little deeper than the last. A school bus making the same route twice a day, 5 days a week, was making those passes in sequence. On a dry October morning, the same road that would strand a vehicle in December was entirely passable. The problem was not the road at any single moment. It was what the road did over the course of a school year, through the cycle of dry and wet, to every component of the vehicle that traveled it. The wooden bus body was not designed for that cycle. It was designed for roads that its makers, working in the coach-building tradition of an earlier era, had assumed would behave the way roads were supposed to behave. Georgia's Piedmont County roads in 1925 did not behave that way. They were new, they were unmaintained at the scale a motor vehicle required, and they transferred everything they had to offer: vibration, torsion, moisture, impact, directly into the structure of any vehicle that traveled them. What specifically could a steel structural frame do on these roads that a wooden one could not? And what did that difference mean for the children who rode inside? Steel did not solve the Georgia road. The Georgia road remained what it was. What steel changed was the relationship between the body and the road. A wooden bus body transmitted the road's forces through its joints. Every vibration that entered the body through the chassis, through the axle, through the springs, through the frame rails, arrived at a wood-to-wood joint somewhere in the body structure. Wood joints under repeated vibration loosened, not all at once, not dramatically. A fraction of movement at each cycle adding to the last, until what had been tight was loose and what had been rigid was flexible in ways it had not been designed to be. A bus that had made 400 morning runs on a Georgia County road was not the same structural object as it had been after 4. It was a body whose joints had been worked by 400 repetitions of the same forces. The coach builders who made wooden bus bodies knew this. It was part of the maintenance requirement. You tightened the joints, you replaced the fasteners. But on a rural Georgia route, operated by a local farmer contracted by a county school board, not a maintenance facility, the interval between tightenings was longer than the interval at which the loosening was occurring. Steel-to-steel joints properly made did not loosen in the same way. The angle iron bows that Luce used in Bluebird number 1 did not flex through the range that Pine members did under the same forces. The structural integrity of the body did not degrade on the same schedule. A bus that had made 400 runs was closer to the same structural object as it had been after 4. This had a direct effect on weather. Wooden body panels that had worked apart from their frames let in Georgia rain. Steel panels properly fitted did not. A farm child riding a wooden bus in a Georgia November rain was riding a bus whose joints had been admitting moisture for months. A steel-framed bus, making the same run in the same rain, was weather-tight in a way the wooden one was not. What did the drivers who first operated these early Bluebird buses on Peach County routes know about their roads? Knowledge that no route sheet had given them? After Bluebird number 1, Luce built 7 more buses between 1927 and 1929. None of them was built for a fleet. None was sold to a district with a transportation department, a depot, or a spare parts arrangement. They went out individually, one bus, one route, one county school at the end of a dirt road running through peach orchards and pecan groves. The routing operations of this period were not administrative systems. A rural Peach County school district in the late 1920s might have a single bus, a single route, and a driver who was a local farmer contracted for the school year. He knew the route because he had farmed along it. He knew the road surface in October and what it became in February. He knew which farm stop required extra time because the family's morning routine ran late, and which stop he could approach without slowing because the children were always at the gate. None of this knowledge came from the school board. None of it was in a route sheet. The school board contracted the driver. The driver learned the route by driving it. The children who rode these early routes absorbed a parallel knowledge that was never recorded and never articulated. The specific sequence of pickup stops, which farm came before which other farm. What the gap between stops felt like in the body of a child sitting in the second row. The specific engine sound the bus made on the one slight rise the route included. The specific quality of the ride at the creek crossing without the bridge, where the driver always slowed to a specific speed, because the approach had a specific crown surface that required it. These were not lessons. They were repetitions. The route built this knowledge into the children who rode it the way any repeated experience builds knowledge. Without announcement, without intention, without the possibility of being explicitly taught. Twice a day, 5 days a week, for 9 years. When the Great Depression arrived and car sales at Luce's dealerships collapsed by 95%, what kept these 8 buses and the small operation that had built them alive? Between 1929 and 1931, Albert Luce produced 9 bus bodies total, not 9 in a year, 9 across 3 years. The Depression had arrived, and it had arrived for Luce the way it arrived for every automobile dealer in rural America. The customers stopped buying. Car sales at his 2 Ford dealerships, Fort Valley and Perry, dropped by 95% in 1931. Not a downturn, a near-complete cessation. The Fort Valley and Perry communities where Luce had sold Ford vehicles for years could not afford to buy them. The farm income that had supported those purchases had collapsed along with commodity prices. A Ford dealer in Middle Georgia in 1931 who had been selling 20 vehicles a month in 1928 was selling 1. The bus operation had remained a side project through the late 1920s, 8 buses between 1927 and 1929, built in the back of the dealership, sold individually to local buyers who used them for school transportation. It was not a bus company. It was a Ford dealer who also, occasionally, built a better bus than the ones his customers had been getting. By 1931, the distinction between side project and survival had collapsed. Luce could not sustain the dealerships. In 1932, he sold both, Fort Valley and Perry, and received $12,000 for them combined. He used that $12,000 to start a company whose sole business was building school buses. He found a rented peach packing shed in Perry, Georgia, and in it he began producing bus bodies at a scale the back of a dealership had not allowed. The first year, he produced 25 bodies. Not 25 in September, 25 for the year. Each one sold to a small school district that had concluded, as more and more rural districts were concluding in the early 1930s, that consolidating small local schools into larger facilities required transportation, and that transportation required a bus that could be trusted to make the route day after day without failing. What was it about school bus orders, specifically, that remained viable when automobile sales had collapsed entirely? School districts had not stopped needing buses. That is the specific answer to what kept Bluebird alive when automobile sales had collapsed. Georgia school districts in the early 1930s were under growing pressure from state education departments to consolidate, to close the one-room schoolhouses and two-room district schools, scattered across rural counties, and move students to larger central facilities. Consolidation required transportation. A district that had sent children to school on foot or by farm wagon to a school a mile away now needed to move them 8 or 10 miles to a building they could not walk to. The bus was not optional equipment in this arrangement. It was the arrangement, and the bus that failed before it was paid off was a bus the district had to replace at a cost Depression-era school boards could not defer indefinitely. The economic argument for durability was, paradoxically, strongest when money was scarcest. A district that paid more for a Bluebird body in 1932 and extracted 5 additional years of service from it than a cheaper wooden-bodied alternative gave the same money represented a rational capital decision under constrained conditions. Lower cost per year of service, not cheaper to buy, cheaper to own. This was the argument Bluebird's buses had been making on Georgia roads since 1927, without Bluebird needing to articulate it. The durability was the argument. Production in 1934 reached 87 bodies, nearly triple the 25 of the first full year. Bluebird had moved from the Perry Peach packing shed to a livery stable in Fort Valley. In the early 1930s, school children who saw a blue and yellow demonstrator bus parked outside a Georgia school had called it a pretty Bluebird. Luce kept the name. By 1934, the name had a factory to go with it. The drivers who operated these early Bluebird routes in Depression-era Georgia and the neighboring states knew their roads in ways no route sheet ever captured. What was that knowledge, and how had it been built? The drivers of these early Bluebird routes in Georgia and the neighboring southern states in the 1930s were not in any formal sense school bus drivers. They were local men, farmers most of them, contracted by county school boards that had no transportation department, no driver qualification standard, and no route supervision beyond the expectation that the children would arrive and be returned. A driver's credential was his availability and his ability to operate the vehicle. His qualification was that he lived near the route. What he brought to the job that no training document had given him was that he had lived near the route. He had farmed along it, driven farm equipment over it through multiple seasons, and accumulated through that daily proximity a specific knowledge of how the road behaved. He knew the stretch that became impassable 3 days after sustained rain. He knew the creek crossing where the concrete marker's second line was the threshold between passable and inadvisable. He knew which family's children were always at the gate and which family needed 2 beats of the horn after the bus stopped because the children were still eating breakfast when the bus arrived. He had not been taught these things. He had driven past those farms on those roads through enough mornings for the mornings to have taught him. When this driver retired after 12 years, or 8 or 4, the knowledge retired with him. Not because the school board failed to ask him to write it down, because there was no form in which it could be written. The second creek marker read at normal flow was not in any manual. The Brantley family's breakfast schedule was not operational data. These facts were in the driver, assembled there over years of daily contact with the specific road and the specific families along it, and they had no existence anywhere else. The driver who took the route next learned it from a sheet that listed the stops and the mileage. What the sheet did not contain, the first mud season taught him. The children who rode this route every day built their own parallel knowledge of the same road. encoded not in memory but in the body. What was it? A farm child in Peach County or Houston County, who had ridden a Bluebird bus route for 4 or 5 school years, knew things about that route that no adult had told them and that no school had thought to teach, not as propositions, as physical facts encoded in the body before they were available to the mind. The way adults know their own houses in the dark, not because they have memorized the distances, but because the distances have been traveled often enough to be automatic. The steel body contributed to this. The specific sounds the bus made on the Georgia road were, for a child who had ridden it through hundreds of mornings, the sounds of the route. The earlier wooden buses, the ones their parents described, or that some older children had ridden before the Bluebird, produced a working structural noise as they aged, the creak and flex of joints that had loosened over a school year. The steel body was quieter in this specific way. Its structural sounds were the mechanical sounds of a vehicle on a road, not the sounds of a body working itself loose from the chassis that carried it. Children who had only ever ridden the steel bus did not know this distinction. They knew only the sounds of their specific route, and those sounds, repeated across hundreds of mornings, became what the route sounded like. What they knew without knowing they knew it. The engine pitch on the one grade the route included, which changed predictably as the bus slowed for the rise and pulled over it, and which told a child, without their looking at a landmark, how far they were from school. The specific quality of the bump at the creek approach, the particular way the morning light entered the windows at the moment the bus turned east onto the final section of the route. None of this had been pointed out. All of it had been absorbed. When the school consolidated and the route changed, the sounds changed. The engine pitch was on a different grade. The morning light came through different windows. The new route had its own character, and that character was unfamiliar. Not because the child was new to bus riding, but because the knowledge the old route had built in them had nowhere to transfer. How did the engineering argument that had kept Bluebird alive in Georgia travel, without advertising, without a sales force, into the broader American South? The argument Bluebird's buses made on Georgia roads traveled by the same mechanism that had built the company in the first place. A county school superintendent who had bought a Bluebird body and found it still structurally sound when a cheaper wooden body alternative purchased the same year was already failing. Talked to the superintendent in the next county. Rural school administrators in the 1930s South moved through informal professional circuits, state education conferences, county board meetings, the lateral communication of people facing the same constrained budgets and the same unimproved roads. A bus that outlasted its competitors was operational intelligence that circulated in these circuits without Bluebird needing to place it there. By the mid-1930s, Bluebird was selling buses outside Georgia, into Alabama, the Carolinas, states across the South where the road conditions that had defeated wooden bus bodies in Peach County were defeating them on similar clay and gravel routes. The steel structural frame translated without modification. The Georgia road had been the test. The other southern roads confirmed what the test had proven. In 1937, Bluebird introduced fully all-steel bus bodies. The steel frame and wood panel construction of the early 1930s, giving way to bodies whose exterior panels were also steel, not wood. This had been driven in part by a series of deadly school bus and train collisions in the mid-1930s, which focused national attention on bus structural integrity in a way that no manufacturer could ignore. The all-steel body that Bluebird introduced in 1937 was an extension of the logic Luce had applied in 1927, carried to its conclusion. The 1939 National School Bus Standards Conference established the first formal national requirements for school bus construction, safety, and the specific yellow paint that would standardize the color of American school buses across the country. Bluebird was already building to the structural standard the conference formalized. 12 years of Georgia road conditions had been a more demanding test than the standards required. What the post-war years demanded from a national manufacturer, and how Albert Luce responded to it, pushed Bluebird beyond the body-on-chassis model that had defined it since 1927. The post-war years arrived with Bluebird ranked 7th among 12 major American school bus manufacturers. It was not the company's worst position, but the world it was operating in had changed. The baby boom was adding school-age children to American classrooms at a rate the system had not previously seen. School consolidation was accelerating, eliminating smaller local schools and routing children to larger central facilities on routes that were longer, serving more students, demanding more from the vehicles that ran them. The Ford and Chevrolet truck chassis that Bluebird had been mounting bus bodies on were adequate platforms, but they were platforms designed for general commercial use, not specifically for the operational requirements of a school bus route. In 1948, Albert Luce attended the Paris Motor Show and saw a European flat-front bus design. The driver positioned over the front axle, the entire length of the vehicle available for passengers, rather than the conventional forward engine arrangement. He brought the design logic back to Fort Valley. 2 years of development followed. In 1952, Bluebird introduced the All-American, a transit-style flat-front school bus, built on a chassis that Bluebird itself had engineered. Not a truck chassis, a school bus chassis designed from the wheel up for the specific load, the specific road surface, and the specific daily operating cycle that a school bus route required. Bluebird was the first school bus manufacturer in the United States to produce its own chassis. It has built the chassis for every full-size bus it has produced since. The All-American's flat front, the forward control driver position, the interior length the transit-style layout produced. These became the design reference point for the American school bus industry. Competitors adopted the same logic. The school bus that American children would ride through the 1960s and 1970s was, in its basic form, the shape that Albert Luce brought back from Paris in 1948 and his engineers built in Fort Valley in 1952. What had started as angle iron bows and a wooden body in the back of a Georgia Ford dealership was now a complete chassis, manufactured in-house, for a vehicle that no longer pretended to be a truck with passengers. What did Fort Valley look like, and what had Bluebird become by the time the man who had started all of it died? By the early 1960s, Bluebird Body Company was the 4th largest school bus manufacturer in the United States. Fort Valley was no longer a small town with a bus shop behind a Ford dealership. The Bluebird facility in Fort Valley was a manufacturing complex. In 1958, Bluebird Canada had opened in Brantford, Ontario. In 1962, Bluebird Midwest opened in Mount Pleasant, Iowa. The name Fort Valley, Georgia, USA, was traveling on buses to school districts in states that Albert Luce had never visited. The buses of 1962 were not the buses of 1927. The roads they ran on were not the roads of 1925. The paved road network had reached into rural Georgia and the rural South and the rural Midwest with a thoroughness that the New Deal and the post-war highway programs had made possible. The specific failure mode that had started Bluebird, a wooden bus body failing on an unimproved Georgia road before it was paid off, was less urgent as a design problem in 1962 than it had been in 1925. The road surface had caught the bus. Albert Luce Sr. died in 1962. He had built the first bus in the back of a Fort Valley Ford dealership at 38, and he died with his company as the 4th largest in a national industry at 74. His sons George, Albert Buddy Jr., and Joseph assumed control. Over the following 2 decades, they would take Bluebird from 4th to 1st. By the mid-1980s, 1 in every 3 new school buses sold in North America was a Bluebird. What the early buses had built in the drivers who drove them, the route knowledge, the road knowledge, the seasonal knowledge, was not carried in any Bluebird vehicle. It was carried in the drivers. And when those drivers retired, it retired with them. What the early buses had built in the children who rode them, the route encoded in the body, the sounds that meant 20 minutes, the engine note that meant 5, was not carried in any school record. It was carried in the people those children became. And when those people moved or the routes changed or the schools closed, it ceased without being recorded. If you rode a Bluebird, or any school bus, on any road, in any decade? Put it in the comments. What do you remember about the ride? A bump in the road that told you where you were? A driver who knew something about the route you only understood years later?